here today to take you through limit of a function. Okay. Okay. In normal way, when we say limit, what we mean is that it is a point that you cannot pass by, or you cannot exceed or extend. That is what it is about the limit. But in mathematics way, when we say limit is what? Is a function or a sequence where the sequence is what? Is approaching, or where the function is approaching. It could approach what? A certain number, or let's say I have a limit of what? As x approaches what? 1. Okay, so here where x is approaching is what? Is 1. It shouldn't what? Exceed 1. Okay, it should goes up to what? Up to 1. That is what we mean about limit in what? In mathematics. Okay, so here I made mention of what? Function. I said limit is a function. Okay, so in general way, limit as x approaches what? C, f of what? X is equal to L. L is the outcome of what? Of the limit, the whole of the limit. So here I'm going to define the terms in what? In the equation. F of x is the function we are talking about. X approaching C is, as the name sound, here x is approaching C. Okay, so here, and C is any what? Any number, any constant, any number at all. Okay, it could be big as you could imagine. Okay, so this is the terms in what? In the equation. But then what is the function we are talking about? A function is a relation from what? A set of input to a set of what? Possible outputs. Example of a function, I can get a function f of x which is equal to x. When I have x equal to 1, when I substitute 1 into the equation, then the outcome of the of this equation is what? Is 1. Okay, I can also get another what? Another function, example of function here. So that is what we mean about function. But here we have two main ways. A function can be continuous or discontinuous. Okay, so here a function being continuous, for suppose I have a line, this line is continuous, continuous line. When I bring a gap in, it is not a continuous function. This one, the line is not continuous because I have a gap in. Okay, I can also have something like this, and this one is also continuous. But then when I bring a gap in between, it is not continuous. Okay, so in mathematics way, when we say a function is continuous, what does it mean? Okay, so let's use a normal line, a line like this. Okay, remember I told you that limit is a point that you cannot what? Extend or bypass. Okay, so here this line is continuous. Okay, so if it is continuous, then it means that every point I pick on what? On the line should exist. Okay, so in math we have 4 what? Properties that holds when a function is what? Continuous. So first of all, if I have a function, okay, let me list the properties. First one, you should define your function. You should define the function you are talking about, f of s, should be defined. That is the function you are talking about. Okay, second, if you pick every point on the line, it should what? It should exist. F of what? C must also what? Exist. Okay, third, the function that you are talking about, if you take a limit of what? Of the left hand side, it should be equal to what? The limit of what? Of the right hand side. So if I have a limit as s approaches what? C, that is the left hand side, f of what? X should be equal to what? Limit as x approaches what? C, positive, which is what? The right hand side, f of what? X. So this one should exist. And the last one, the fourth one, the limit as x approaches what? C, f of what? X should be equal to what? F of what? C. Here it is simple. We know that if you have the function f of what? X, which is equal to x, in place of what? F of x, you can get a limit as x approaches what? C. Then you have what? X, because here x is what? F of x is equal to x, and you can substitute into the equation and get something like this. And in the equation, you cannot also put what? C, because x is approaching C. So when you see x, you put C. Okay, so limit x approaches what? C, x is equal to what? C, because wherever you see what? X, you just what? Put in what? C. And this is what it means. This one that I'm talking about, the top one. Limit as x approaches C, f of x is equal to limit s approaches what? C, f, sorry. So this one, in place of what? F of x, I just put in what? X. So I get x, then I just substitute what? C. Then I get what? C. And it will also mean what? F of what? C. Okay. Then here, that is what? That is the idea of what? Continuity, for it being what? Continuous. Okay. So if these properties exist, then it means that the function is what? Continuous. If one of these properties fails, it means that the function is what? Discontinuous. And discontinuous means that I do have a gap in between the line. Okay. So here, this C I'm talking about, C could be what? Any point picking from what? From the line. Any point from the line. You can pick any point from the line, and when you substitute into the equation, that point should what? Exist. Remember, this line I drew, it is just like what? Joint of a point. You joining a point. The line, this line I'm talking about, it's just joining of what? Points. Joining of so many points. But because what? We always what? Extend it fast. Then you could not see that it is a point that we are joining. By then, it is a point we are joining automatically here. So here, since we don't have any gap, we say that this line is continuous. But when the line comes in, then it becomes, when the gap comes in, then it becomes what? Discontinuous. Okay. So let's go back to the limit we are doing. So for a limit of a function to exist, first of all, that function we are talking about should be what? Should be continuous. Okay. And if it is continuous, if you pick any point from the line, that point should what? Should exist. And the another one is the left hand limit should be equal to what? The right hand limit. I'll solve more examples so that you understand what I'm talking about. Okay. Let's proceed and what? Continue it. So the next one we are talking about is what? Is a limit theorem. Remember, in mathematics, every topic you pick, or some of the topic we pick, attached with what? Properties. And we have a theorem governing what we are talking about. So we have a theorem called limit theorem. This limit theorem helps you to understand the limit better, the way you want it to be. Okay. So limit theorem. So this theorem, they are 5 or 6. Okay. So the first theorem, the first theorem is the limit of what? Of a constant. Limit of a constant. Limit of a constant. Here, the limit of a constant is simple. Or before that, when we say theorem, theorem is when we are talking about results, the overall results. In fact, the bigger results. That is what we mean about theorem. Okay. So limit of what? Of a constant is simple. When I pick a limit of any number, let's say 5, as x approaches what? C, it is always the what? The number itself. In fact, it is the constant itself. Whenever you find a limit of what? Any constant, it is what? The answer you will get is what? Is the constant itself. So the limit of what? The limit of what? Of a constant is the number itself. Is the number itself. Or the constant itself. That is the limit of what? Of a constant. Example. Take a limit of what? 5 as s approaches what? Any number, let's say c, or let me make it 10. It is always equal to what? 5. Remember, we said the limit of what? Of a constant is the constant itself, the number itself. Okay, equal to 5. So here, it doesn't matter where the limit is approaching. It is always what? The constant number. Okay. So that is the example. I can give another example. Limit as s approaches what? 1000. Then we have what? 10. The answer is what? 10. It is the number itself. Okay. The second theorem is the limit of what? Identity function. Theorem 2. The limit of what? Identity function. The limit of what? Identity function. The limit of identity function. This one, what it means that whenever you have a limit of what? Any identity function. Suppose I have what? F of x, which is equal to what? X. Okay. What this one is saying that whenever I take limit of what? Limit as x approaches c, f of what? X, or limit as x approaches c, x, always it is equal to what? Where the limit is approaching. So it means that example is, if I have a limit as x approaches what? C of x, the answer it will give me will be what? Will be c. So this one is simple. I just substitute in what? C, then I get what? My c. Okay, so always whenever you take a limit of any identity function, which is what? X, it is always equal to what? Where the limit is what? Is approaching. That is what? The number. So here you can see that if I have example, for example, if I have a limit as x approaches 10, then I have what? X. It is going to give me what? 10. That is the answer for what I was talking about. That is the example of what? Limit of identity function. Limit of identity function. Okay. So the third one, theorem 3, is the limit of what? Of sum. The limit of what? Sum. The limit of what? The limit of the sum or difference of two functions. The limit of the sum or the difference of what? Two functions. Okay, so this one is simple. Whenever you want to find the limit of what? Of any what? Two function. What is saying that the final answer is what? Is what? Is the sum of what? Of the individual results, the individual function. Okay, so it's simple. I'm going to give examples so that you understand it what better. So here, suppose I have this limit. Suppose I have a limit as s approaches what? C, then f of x equal to what? L. That is what? 1. And I also have another what? As x approaches C, g of what? X equal to what? M. These ones, they are what? Two what? Equations. Two limit equation. So what? I want to sum up what? This limit. Equation 1 and equation 2. And mind you, before you can what? You can do for this one, you can sum up this one. So these two limits should exist, and where they are approaching should be what? Should be the same. It means that if x is approaching C, the second equation x should also be what? Approaching what? C. So if I want to sum up these two equations, it is simple. It's going to be what? Limit as x approaches C, f of what? X plus what? Limit as x approaches C, g of what? X, which is also equal to what? L plus what? M. Okay, and this one is simple. This one, this whole thing, you can also write them as what? Limit as x approaches what? C, then f of what? X plus what? G of what? X, which is equal to what? L plus what? M. Okay, so here I'm going to give an example so that you understand it better. So suppose I have limit as x approaches what? 10. Then I have what? 2x squared plus what? 1. That is what? Equation 1. And I have another limit as x approaches what? 10. Then I have what? 3x plus 2. That is what? Equation 2. And I want to sum up this limit. Mind you, always check. This one should be the same. Where x is approaching should what? Should be the same. Other than that, you cannot proceed. Because, and always one of these limits should what? Should exist. So to sum up this, it is simple. You just check from the equation. What you have to do is that you have limits as x approaches what? 10. Then you have what? 2x squared plus what? 1 plus limit as x approaches 10, then what? 3x plus what? 2. Okay, in the other way you can also write it as what? As x approaches what? 10, then we have what? X squared plus 1, then plus what? 3x plus what? 2. Okay, so here x is approaching 10. Where you see x, you just substitute in what? 10. just substitute in 10. So it means that I'm going to get limit as x approaching what? 10. Let me substitute in straight away so that you get. So it means I'm going to get 2 10 squared two 10 squared plus what? 1 plus 3 10 plus what? 2. Okay, so I'm going to get this 1 times this, which is 100, 200 plus what? 1. This 1 times this, which is what? 30 plus what? 2. So at the end of the day, I'm going to get what? 233. That is my final answer for summing upward and limit. The difference is simple. The difference, you just change the sign. If I have these two limits and I want to find the difference of what? These two functions, it is simple. It is just what? The one of the equation minus the other. Okay, so I just change the sign. So what I have to do is what? I just have to change the sign. So limit as x approaches what? 10. Then I have for 2x squared plus what? 1. The whole of this one minus what? Limit as s approaches what? 10. Then what? 3x plus 2. Okay. That is the difference. Then you use the normal way on it. So I'm going to get limit as x approaches what? 10. Then I have what? 2x squared plus what? 1. Minus 3x plus what? 2. Then I just substitute in what? 10. Then to get what? My final answer. That is the what? The idea of what? Limit of what? Sum and what? And the difference of what? Two functions. Okay. About the last part one I'll talk about is what? Is the limit of what? Of a line, or limit of what? A linear function. That is the theorem 4. Theorem 4. The limit of what? A linear function. Linear what? Function. Okay. So this one, it is simple. I'm talking about, when I say linear, I'm talking about a straight line. The limit of what? Of a straight line. And we all know that we have a function x of what? This one, which is equal to m of what? X plus what? B. Where b and where m and b are what? Are constant. Where m and b are what? Are constant. Okay. And they belong to what? The R. Okay. So here, what you have to do is you're going to take the limit of what? Of the function. So I'm going to get limit as x approaches what? C. Then f of what? X. Which is equal to what? Limit as x approaches what? C. Then what? The whole of what? This one. Mx plus what? B. So what I have to do is what? I just substitute C into where I see x. So it means that I'm going to get limit, I'm going to get MC plus what? B. And that is what? My answer for this one. So let me take an example. So suppose I have something like this. As x approaches what? 10. And I have 2x plus what? 1. So this one, straight away, I just substitute 10 into the equation. Then I'm going to get what? 2 times what? 10 plus what? 1, which is equal to what? 21. Okay. That is what? The idea of limit of what? The linear function. So the last one I'll talk about is the limit of what? Limit of a product. Okay, that isn't the last one. That one's supposed to be the last but one. That the limit of a product. Product of what? Two functions. So suppose I have the same thing. Suppose I have two functions. The limit of what? Two functions. Just as what I give. And when the limit approaching should be what? Should be the same. Okay, which is equal to what? L. That is the equation 1. That is, let me call this one Theorem 5. Theorem 5. Okay, and that one is the limit of what? Product of what? Two functions. Okay, so, and I have another limit as x approaches c, which is also equal to what? M. And it's equation 2. So if I want to find the product of this one, it's simple. I'm going to get limit as x approaches c, then f of what? X times limit x approaches c g of what? X, which is equal to what? L times what? M. Okay, and this one, the whole of this one, you can just write them as what? Limit as x approaches what? C. Then you have what? F of what? X times what? G of what? X. And it's equal to what? L times what? M. Okay, that is the idea of what? Of the product. So if I give you two functions, for example, if I give you f of x, okay, limit, I'm giving you a limit as x approaches what? 10, then I have 2x plus what? 2. That is what? One limit, 1, equation 1, and another limit as x approaches what? 10, then I have what? 3, and I ask him to what? To find the product of this one. This one is equation 2. It is simple. So you're going to get limit as x approaches what? 10, then 2x plus 2, the whole of this one, times what? Limit as x approaches what? 10, then what? 3. And here you can also write them as limit as x approaches what? 10 to the of this one times what? 3. So here you just substitute in what? 10. So where you see s, you put in what? 10. So if you do that, what do you get? You're going to get 2 times what? 10 plus 2 times what? 3. So at the end of the day, you're going to get 22 times what? 3, which is what? 66. Okay. That is what? The limit of what? Of a product of two functions.